Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to see the analysis of Allen key. So we will first start by talking about what is Allen key. Allen keys, or also known as hexagonal keys, are a tool used to screw, which we find very frequently in most toolboxes. These type of wrenches are famous for resisting a greater torque than other type of screws, and for this reason we can find them in a wide variety of applications. There are various advantages of Allen keys. As already mentioned, Allen keys are a tool that is used very frequently, and this type of tool has certain advantages over other types of tools that make them stand out. Allen keys are simple in design with a hexagonal shaped shaft and are small in size and light in weight compared to other types of tools. Obviously, there are different sizes of Allen keys, and those of large sizes, we can say that they are not light at all. Being a key that is inserted into the screw slot, the contact surface between the screw and the key is important, and that is why it can exert a greater tightening torque than other bits or screwdrivers. On the other hand, and thanks to the fact that the key enters completely into the screw, it reduces the deformation that frequently occurs in other type of screws. By having different presentations of Allen keys, they can be easily combined with a bit holder screwdriver. Being a very simple tool, we can find all kinds of Allen key sizes, from the smallest sizes to the larger sizes. Here you can see some diagrams of how Allen key looks like. These are the Allen keys. You can see the smallest size is available, and so is the largest size. You can use them according to the size of the screw in which you are going to fit this key and loosen it. So this part can be put inside the screw, and you can give a torque from here so that the screw is loosened, or you can attach this end also and you can give a torque from this side. It can be used from both the sides. So that's one of the advantages of using an Allen key. And since this part or maybe this part goes completely into the screw, so what happens is you can give a more amount of torque, unlike the other ones where only a small part of it goes inside the screw and you have to just give a torque. But here you need to insert the entire part. There's a slot in which you are going to put this Allen key. Say this is the length of the slot, or this much is the length of the slot. So what happens is a longer edge goes inside, and so it is easier to use. These are the sets or the tool boxes in which these Allen keys are available in the market. These kind of folding Allen keys are also available these days in the market. So these can be easily folded and used, and also they can be kept very handy. For example, if a person is using it in his bicycle for some kind of repair work, so it is very easy for the cyclist to carry this kind of an Allen key. How are hex keys used? The use of Allen keys is very simple. We simply have to insert the hexagonal end of the key into the head of the screw and turn our wrist to exert the necessary tightening torque. Thanks to its shape, we can use the Allen key from either side and exert a tightening torque in each case. Different types of hex keys. L-style Allen wrenches. This is the standard Allen key and is easily found anywhere. Due to its L shape, it can reach into tight spots and provide control when needed. If you're looking to get only one set, this would be a perfect option. There are many choices available in the market, though a 1.5 to 10 mm is a good value purchase. T-handle is the next type. If you want to see, this is the L style Allen wrench, and this is what we are going to analyze in this session. There's something called as T-handle. This is a popular type mostly used in motorsport applications. Due to the T-handle, you can spin the wrench quickly while allowing enough leverage in common usage. Beta 951 wrenches allow it to slide into a position to create an L-shaped tool. These are quickly becoming popular among bike mechanisms. This is a T-handle type of hex key. Next is P-handle. These types of Allen keys can be seen in lots of professional workshops. These are oversized L wrench with a comfortable grip that gives them similar benefits as that of T-handle. So this is how the P-handle looks like. You can see there's a beautiful grip given here. So you can use it very easily from this end. And here at this end you can see that there is a ball ending. A ball shape is given at this end. Next type is folding hex key. These are mostly loved by bicyclists and motorbike riders. Unlike other Allen keys, it is nearly impossible to lose a folding hex wrench as they are enclosed in the handle. They are normally folded out at 90 degrees from the storage handle to give maximum torque. So this is how it looks like. The maximum angle it can give is 90 degree. So whichever shape or size you need of the hex key, you can use it, and the rest can be folded inside. So this is very comfortable to use and also to carry wherever you require. The next type is a torque wrench. A torque wrench is an important part of any workshop, especially when working with delicate components, but it is definitely not a replacement for hex wrench. So this is another type of wrench which is used. This part is fixed into the screw, and from this end you give a torque. So that's how this can be used. We will be analyzing torque wrench in the next session. The next type is ball hex sets. These wrench sets are distinctive from other hex sets available in the market. They have ball molded head at tight edges where L-formed wrenches can't exactly reach. So you can see here there are ball molded head. These can be used where your L-formed wrenches, this one, cannot fit in. So that's where you can use these kind of a shape. Allen screwdriver, this is something you must have seen. This is very commonly available in the market these days. This is very handy when low torque and tight clearance are the main factors on which you are working. This is best for adjusting lever and some disc brake levers. The most common size used in the market is 1.5 to 5 mm of this screwdriver. Next, we will see uses for Allen keys. It is used for bicycle repair. These are the dominant tools used for bike repairs and size adjustments. The wide range of sizes allows them to be used in different applications, and their compact size makes them easy to carry. If you are a frequent rider, you can pick a set of folding hex keys. Furniture repairs. Allen screws are an essential piece of hardware for securing furniture at its place. It allows assembling the furniture without adding any unnecessary bulk pieces. Their compact design allows them discreet in appearance and strong in fastening. Since furniture pieces can have tight spaces and require long reach, you can use a set of long arm hex keys. Next application is in cars and motorcycles. You would need an Allen key set for the proper maintenance of your car. Allen keys are helpful while assessing the areas under the seat and places under the dash, like behind the glove compartment. T-handle hex wrenches are recommended for cars and motorcycles repair. Next is tools. Apart from other uses, Allen keys can also be helpful in maintaining and repairing heavy tools and machinery. Drill bits rely on it to secure the bit into place. Similarly, power saws of all varieties require Allen keys to change blades or for minor adjustments. Short arm Allen keys are mostly used to perform these tasks. The last application is in electronics. Allen wrenches are becoming very popular with people dealing with repairing and maintaining electronics. As electronics are becoming more and more compact in size, Allen keys are being used to support their size. Computers and large television screens are held together with these screws from the backside. You can buy torque wrenches for this purpose. Now this is one of the Allen key specifications. You can see here, this side is the longer arm, this is the shorter arm. This length is B in mm, it's given here shortest length in mm. A is the length in mm here, it's a long side. And the Allen key size required is say 2.5. The screw size or the thread size for which you're going to use is going to be M3. Accordingly, you can read for these screw sizes and which Allen key to use. And for these Allen keys, A and B dimensions are given here. So let me choose the second type, M4, for designing today. I am going to use this length A as 63 and the length of B, that is a shorter arm, is 20. Also, I am going to use the screw size as M4. So the size required is 3 over here. So that's the hex size which we are going to use. So let's design this. And in center over here, what is given is the length of A in inches. Generally, the design or the sizes of Allen key in the market are available either in inches or in mm. You can buy in any one unit system. So we are going to deal with mm. So let's go back to ANSYS. We are going to use static structural module. I'll double click on it. Generally, the material used for Allen key is either stainless steel or some alloy steel which is available in the market. You can change the data by going to engineering data sources, general materials. Alloy steel is not available in this, but what is available is stainless steel. So you can choose that. Go back to project and update project. I'll go to geometry and right click, new design modeler geometry. Units I'll choose as millimeter, XY plane look at. I'll go to sketching and choose a line. I'll just draw up to this blue point. Next I'll go to dimensions and give these dimensions. As we just read, the shorter arm was 20 mm and the vertical length was 63. Next I am going to go to modify and give fillet. Say this is 3 mm. So that gives it a bend over here. Next I'll go back to modeling. ZX plane, that is the perpendicular one. Here I am going to insert a polygon of 6 sides. That's a hexagon. I will give it dimensions. The horizontal distance between these two is 2.5 mm. That's very small. I'll go back to modeling. I'll use the sweep option. So the sketch is the profile and sketch 1 is the path. I'll generate. You can see here, this is the Allen key which is made. So this completes the geometry. Next, I'm going to go to model and double click on it. I'll first go to geometry and give it the material as stainless steel. Next, I'll go to mesh and change the sizing to fine and update. Next, I'll go to static structural and insert fixed support on one end. On the other surface here, I'm going to insert force. I'll change vector to component. This direction is the Z direction. So along the Z axis, I'll give a force of say 100 Newton. So it goes this way. I'll just change it to minus 100. I'll now go to solution and insert deformation total. I'll insert deformation directional. I'll change the direction to Z. I'll insert stress equivalent, strain equivalent. Also, I'll insert stress tool. Here I can see the safety factor. I'll now go to solution and solve. You can see here, this is the total deformation. This value is large because I've given a larger force of 100 Newton. You can just change this to minus 50 and solve once again. The deformation is yet 9 mm, but it's okay. That's how it's going to work. We'll see the directional deformation along the z-axis. It is 0.0126 mm. This is the equivalent stress generated over the body, which is 1267.5 megapascal, and the equivalent strain is 0.0065701. The safety factor here is little less at this edge, but here it is quite high. So it also could be because of the force that we have applied. You could change this force value to a more lesser value, say 10 Newton. That's because the value of the screw size is actually very small. Hence it is taking such lesser value. Now you can see the blue portion has increased, which means it's become more safer. So you can check the total deformation. It is 1.9 mm. Directional deformation has reduced further, and this is the stress value which has now reduced to 5.33 megapascal. The strain is 0.001314. Safety factor obviously has increased because of the force which we are going to apply has reduced. You can further reduce this and you can decide what value is good for your Allen key such that it has a greater life and you can use it without breakdown. So with this, I end the session. I hope you have understood how to analyze an Allen key. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.